Hi, welcome to Cloud on Air, webinars from Google Cloud. My name is Kazan Fields, and I'm a developer advocate. Today, we're going to be talking about Google Kubernetes Engine, or GKE. You can ask questions at any time by submitting them in the box below the screen. We have Googlers on standby to answer them. Let's get started. Google Cloud Platform offers a variety of tools to help you as you consider your application modernization needs and embark on your application modernization journey. Depending on your role within the organization, there are different tools that may better suit your needs. A few of those are listed here. If you're a developer who primarily cares about writing code and creating applications, serverless-style tools might be useful to you. So here we have Knative, which is an open source serverless tool, and Cloud Run, which is our managed service serverless offering. If you are more of a service operator or a site reliability engineer, you might care about the networking, the interactions between applications, observability of applications, and things like that. And so you might be interested in service mesh. In that area, there's the open source Istio project. And within Google Cloud, we have a service mesh offering as well. But today we're going to be talking about infrastructure operators, those who care about the infrastructure that the applications are running on, or who make sure that those applications have everything that they need. And for that, we're going to be talking about Kubernetes and Google Kubernetes Engine, which is our managed Kubernetes service. Why is Google Kubernetes Engine an interesting tool? As opposed to running Kubernetes clusters yourself, what does a managed Kubernetes service offer you that you couldn't get just by running your own Kubernetes? For one thing, managed Kubernetes services are often talked about as being a very easy way to get up and running with Kubernetes. Instead of having to go through the process of deploying Kubernetes yourself, you can basically click a button and have a Kubernetes cluster ready for you. So they're quick to get up and running. The management is somewhat simplified because Google will be taking care of the management of that cluster for you. And you can just worry about all of your applications, making sure that they're running on Kubernetes and any Kubernetes management tasks that you may need to worry about, well, without having to worry about the actual management of Kubernetes itself. We also have great guidance if you are looking to move your applications onto Kubernetes or figure out how to optimize workloads to work on Kubernetes. There's great documentation there that can help guide you, and scaling capabilities. When you're using a managed Kubernetes service, there are useful integrations with other cloud services, such as autoscaling, so that if you have scaling needs where you need to suddenly make your cluster bigger, add more nodes to it, we have integrations with that and integrations with several other Google Cloud offerings that might be useful to you. And GKE is open. Google Kubernetes Engine, because it's using the standard upstream Kubernetes project. So if you've ever used Kubernetes anywhere else, you'll have the same experience here, the same management tools, basically the same features that you expect from Kubernetes, because it is the standard upstream project. And another reason that customers choose Google Kubernetes Engine is that they know that Google has been developing and using containers to manage our own applications for over 12 years. With this long history of running containers, customers trust us with their own containerized workloads. And if you're not familiar with the history of the Kubernetes project, it is actually based on Google Borg, which is Google's own internal system for running containers that we developed years and years ago. And so at one point, we decided to kind of generalize that and make it more available, open source, useful for more use cases. And that's kind of where the Kubernetes project came from. If you're interested in the history of Borg and all of that, you can actually look that stuff up on the internet if you want to. And everything at Google runs in containers, even today. So Gmail, web search, maps, pretty much any service that you can think of runs in containers. Even Google's cloud platform, we run our VMs in containers. If you're familiar with containers, you'll notice that that is the opposite of what you normally hear. Often you hear about running containers in VMs, but here at Google, we even run VMs in containers. We launch several billion containers per week. So you know what we're doing when we're running container clusters. So let's talk a little bit more about Kubernetes. Kubernetes, the word, comes from the Greek term for helmsman. It's also the root of words like governor and cybernetic. And when you're running containers, you have to run them on some hardware, whether that's bare metal machinery or actual virtual machines on bare metal machinery. Whatever actual underlying infrastructure you're running those containers on becomes quite challenging when you're running containers at scale. So Kubernetes gives you a method for saying, this is what I need my environment to look like. This is how many containers I want running, how many copies of applications. Here are the needs of this application. If they need something in particular from the infrastructure that it's running on, you can specify that. So Kubernetes basically allows you to handle container orchestration at scale. Like I mentioned before, this is based on Google's Borg system, so we have a long history of running this type of thing. It supports multiple cloud and bare metal environments because it's an open source project with no particular affiliation with any type of environment. So there are Kubernetes clusters that are run on-prem, on various cloud platforms, and all sorts of different environments. So you'll know that you'll be getting the same experience in terms of using Kubernetes wherever you go. And Kubernetes supports multiple container runtimes. If you've used containers before, you've probably used Docker containers, which are the most common type of container. But there are other types that are useful for various reasons, various requirements of your workloads. So Kubernetes is able to work with multiple different types of container runtimes, which can be very useful. And like I said, Kubernetes is 100% open source and it's written in Go. So you can find it on GitHub and even check out the source code if you wanted to. And Kubernetes is all about managing applications and letting Kubernetes kind of handle the challenges of managing the machines that those applications will be running on. So GKE, coming back to the managed Kubernetes service, is all about Kubernetes the easy way. If you're familiar with Kubernetes, you might have heard of Kubernetes the hard way, which is a guide for deploying Kubernetes from scratch by Kelsey Hightower. You can find it on GitHub. It's a really useful way to understand how Kubernetes works and all of the underlying components. But it is called Kubernetes the hard way for a reason. It can be kind of difficult to run your own Kubernetes clusters, deploy them, manage them, deal with all of the configuration options that you may want to set in a Kubernetes deployment. So going with a managed Kubernetes service just makes things a little bit easier for you. The managed Kubernetes provider will be managing the control plane for you. We'll have certain settings with the deployment. So there's a lot that you don't have to worry about, and you can just basically hit a button and get a Kubernetes cluster, which is a really useful way to interact with Kubernetes. And we talk about GKE being enterprise-grade container management. What do we mean by that? For one, it's operated by Google Site Reliability Engineers. Site reliability engineering is a discipline that we at Google care a lot about, and we think that site reliability engineers are pretty awesome. They do a great job of keeping things going, and we even have a book out there about site reliability engineering if you're interested in that. So we have these awesome folks taking care of your clusters for you. We also have a 99.95% regional SLA, service level agreement. So this is an enterprise type of feature so that you know what kind of availability you can expect. There's more to it than just that. So if you're interested in what types of expectations you should have around the service, you can look more into that. But here's one example of an enterprise grade feature. Secure by default. This is an interesting point. Because if you've ever run Kubernetes yourself, you're probably aware that running Kubernetes, it's by default not the most secure, and there are good reasons for that. There are many use cases for Kubernetes that may require special security configurations. So enforcing a default isn't the best way to go for the Kubernetes open source project, but since we're managing it for you, we can set some of that stuff up so that it's a bit more secure. And we also have the capabilities to do a bit more security with the cloud integrations that I mentioned earlier. Private and hybrid networking. One thing when you consider moving your workloads to Kubernetes is how are those workloads going to interact with one another? How are they going to interact with applications outside of the Kubernetes cluster? These considerations can be pretty challenging and pretty difficult to set up yourself if you're having to set up the networking. So Google offers some really useful options around doing private networking, where all of your workloads running within Kubernetes can talk to each other, but maybe they're not available on the internet, versus hybrid networking, where your Kubernetes cluster can interact with multiple different environments in other places. And we have industry-leading scale up to 15,000 nodes. So this is related to the networking bullet point in that Kubernetes can be pretty challenging to run on its own. And if you're running it on your own, you may have trouble getting up to the maximum number of nodes that you can have in a Kubernetes cluster. As a group that's very experienced with running container clusters and very experienced with Kubernetes, we were able to get some really high utilization with being able to get a lot of nodes into your Kubernetes cluster. So that's pretty exciting. And what types of applications and workloads can you run on Kubernetes? Kubernetes clusters are very well known for running cloud-native workloads, but that's not the only thing they can do. They can also run stateful applications. There are some considerations that you have to make when you're considering putting a stateful application on Kubernetes. We have some useful guidance around that if you're interested in that. AI and machine learning workloads are often run on Kubernetes, and legacy workloads. If you have more traditionally architected applications that you're trying to move into Kubernetes to modernize into containers, we have some guidance and some tooling around that you might find interesting. So I mentioned secure by default earlier. I want to dive into that a little bit more to show you kind of some of the features and products that relate to that. So for one thing, there's identity and access management. So we've got our Google security team, and we have features like Cloud IAM and RBAC, role-based access control, both in terms of Google Cloud and in terms of Kubernetes itself. So there are some useful identity and access security tools there. Certified images. Google will test operating system images that are run on your actual Kubernetes nodes to make sure that they're scanned for vulnerabilities and we know about any challenges there. So you can use those certified images for your nodes. And data encryption, automatic data encryption at rest and in transit for your Kubernetes clusters and workloads. And private clusters. I mentioned earlier private networking versus hybrid networking or interaction with the internet. The ability to access your clusters without the clusters themselves being available on the internet is a useful tool. So that's just a look at a few security features that kind of back up that claim of secure by default. If you want to know more about security features and container security, there's a variety of products and features in that area, and here's a list of some of them, and you can always check them out on the Google Cloud documentation. I also want to talk a little bit about networking. So for one thing, with Google Cloud, you have globally available VPCs. So that allows you to connect to and isolate your clusters no matter where in the globe you may be. We also have global load balancing services. So all of your public services can be behind a load balancer wherever you may be in the world. Networking policies so that you can control the communication between your cluster's pods as well as the cluster and outside applications, depending on where they may be. You can set up network policies to help control that. And Cloud Armor is a Google Cloud product that helps protect against denial of service and other types of attacks. So that's kind of one of those integrations I was talking about earlier with GKE and other cloud products and services. So that's just a few of the networking capabilities that might be relevant to you. If you're interested in learning more about them, here's a few more, and you can always find more in the documentation. But the best way to get a feel for all of this stuff, of course, is to get hands-on with it. So today I'm going to walk you through a quick lab where you can try out creating your own GKE cluster and spinning up an application on Kubernetes for yourself. So let's go over to the demo now. Here we are in Quick Labs, where I'm going to be walking you through sort of an introduction to Google Kubernetes Engine. So if you check out the overview here, it'll give you a little bit of an introduction to what Google Kubernetes Engine is and explain a little bit about cluster orchestration, as I talked about earlier, and tells you a little bit about the different components of Kubernetes that you'll probably want to know about, especially on Google Cloud. So it talks about load balancing, like I mentioned earlier, node pools, which are the actual compute nodes that you'll be running your containers on, which Kubernetes uses to run your containers on. automatic scaling and automatic upgrades. If you've ever run your own Kubernetes clusters, you'll know that Kubernetes upgrades can be quite challenging. So that's a useful feature of managed Kubernetes services. So this is some useful preliminary information. Now to do the lab, there are some setup and requirements instructions here. The main thing that you're going to want to do is, well, I have set up an incognito window here, which will probably be the easiest way for you to do it. They mention that down here further, and I'll explain in a minute what that's used for, but I would go ahead and set it up. And then another pro tip here is to go ahead and read through all of the instructions before you hit the Start Lab button. Because from the time you hit the Start Lab button, you'll have 30 minutes in the Google Cloud platform with the credentials that you have been assigned through Quick Labs to do anything you want to do. So to maximize your time in Google Cloud using these credentials, you're going to want to go ahead and read through the instructions so that you kind of know what you're expecting first. So let's go ahead and start the lab. I'm going to hit the Start Lab button and explain that I am not a robot. And once that finishes, you'll see it come up here with a username, a password, and a GCP product ID. So these have been created just for this Quick Lab. And over here in my incognito window, I'm going to open up console.cloud.google.com. And here I'm going to want to input our username. So I'm going to copy that and paste it right here. Hit next. Then I'm going to copy the password, put it in, accept the terms. And this account is only going to be useful for the 30 minutes while I'm doing this lab. So there's no need to put in a recovery phone number or email or anything. I'm just going to confirm. And now you'll see that we are in the Google Cloud Platform console. It gives us a little welcome message. We agree to the terms of service, agree and continue. And so now you'll see the console up here. The first thing that I'm going to do, just to get a little bit more out of this lab, is I'm going to select a project. And I'm going to copy my GCP project ID from over here and paste that in right here. Open that up. And what that allows me to do is go to the dashboard for that project in the GCP CLI. Then I'm going to close the navigation menu because otherwise it will get in my way as I go between the two windows. And now you can see the dashboard for my Google Cloud project right here. And so this API request graph is going to change as we go through the Quick Lab. So that's pretty cool to see. So that's why I like to go to this. Now we've kind of gone through all of these instructions here. Next thing I need to do is activate the Cloud Shell, which is this button right here. And that will open up a shell in our terminal or in our Chrome window. Which is basically a terminal that we'll use to interact with Google Cloud. We'll use the Google Cloud CLI through this, and we'll also interact with our Kubernetes cluster through this. And that'll take a minute to provision. Now that that's up, the next thing that we're going to want to do is run gcloud auth list. And that'll just tell us some information about the account that we're using and gives us an opportunity to authorize our Google Cloud CLI to make changes to our Google Cloud Platform project. So I'm going to authorize that. And so that gives us a little bit of information. We can see that we're running as our student Quick Labs account. Now I'm going to run gcloud config list project. We want to make sure that we're running in the project that is stated over here in the Quick Labs window. You can see that my project is already set to that. If yours isn't, then you can run gcloud config set project and then put the project ID with a space between project and the ID, and that'll get you set up. And so now the first thing that we're going to do to really get started with the meat of this lab is to set up a default compute zone. So we're going to say gcloud config set compute /zone US Central 1-A. So this tells our Google Cloud CLI when we're creating resources for this project, we want them to be created in the zone US Central 1A. So now we've done that. Our next step is to create our first Kubernetes cluster. This is really easy to do through the CLI. You can just run gcloud container clusters create and then give it a name. I'm just going to call this demo cluster and just hit enter. And then this will take a few minutes to complete. Like I said earlier, your Kubernetes cluster is using actual compute nodes, basically virtual machine instances on the back end to run your containers on. So this is going to take a few minutes while it spins up those compute instances. So once you're done, you'll be able to check your progress, and we'll just wait a minute for that to complete. If you're doing this on your own, you might find it interesting to poke around the dashboard or check out some of the things in the navigation menu. Don't worry, your Cloud Shell will be fine. Even if you somehow close your Cloud Shell, if you hit the Cloud Shell button again and open it up, all of your progress should still be there. So feel free to just explore the console while you wait. Now you can see from the output in our window here that our cluster has completed. It's finished creating. And so we can go over here to our Quick Labs window and check our progress. You can see that it knows that we've created our Kubernetes Engine cluster, and we can move on to the next step. Next, I want to get authentication credentials for the cluster. This is going to allow us to use kubectl, the Kubernetes command line control, to interact with our Kubernetes cluster. So we do that by running another gcloud command. Oops, didn't mean to click that. So we run gcloud container clusters get-credentials. Another pro tip here is to type out each command like I am doing here. That'll help you at least it helps me to learn the commands as I'm running them. So I put in the name of my cluster, which I believe is correct. Yep. So I run that, and it says that a kubeconfig entry has been generated for a demo cluster. We should now be able to run kubectl commands on the cluster, and now we're going to deploy an application to our Kubernetes cluster. So we're going to run kubectl create deployment. Fun fact, you can shorten that to just deploy. Hello server -- image equals gcr.io/google -samples. So this is just a simple hello world app that we're going to use just to show what it's like to deploy an application onto Kubernetes. So once I run that, you'll see deployment.app/hello server was created. So I'm going to check my progress. You'll see that it failed here. It takes it a few minutes sometimes to update. So I'm going to wait just a minute here and then check it again. I can actually keep going with the instructions while I'm waiting. So I'll go ahead and do that. This is going to tell you a little bit of information about the deployment. And the next thing that we need to do is we need to have some way to interact with our application that we just deployed. So we're going to run kubectl expose deployment, which again we can shorten to deploy. Hello-server -- type equals load balancer. port 8080. So what this says is, Kubernetes, I want to create a service that I can use to interact with my deployment called Hello Server. And I want that service to be of type load balancer. So I want you to spin up a load balancer on Google Cloud Platform for me to interact with my deployment. And I want that to be accessible on port 8080. So once we do that, you'll see it outputs service/hello server exposed. And then if you run kubectl get service, or SVC for short, you can see that we've got our hello server application here, type load balancer, and you can see external IP is pending. That's going to change as the load balancer spins up. If you want to watch that happen, you can do kubectl get service -w, and that will watch and wait for the external IP to come up and update you when it does. So this has probably been long enough, so I'm going to check my progress again in the quick lab, and you can see that that's good to go now. So if you have that happen, no worries, just wait a minute and it should be good. You can see now that my service has returned an external IP. So we can now cancel our command waiting for that to happen. So we've seen it. And our next thing is going to be to go and check out the application that we've spun up. I'm going to do that by copying my IP here and putting it in here, and specifying port 8080 as well. So you saw there that I had an issue with my page loading, and that was because I actually mistyped my kubectl create command. So something had gone wrong with my deployment. So I deleted the deployment and then I recreated the deployment by just copy pasting the command. Something that can happen when you're typing out the commands. So if you see that happen, you can redo the deployment. You don't have to redo the service. The service will automatically connect when you create the new deployment. So that's all I did. I just deleted the deployment, brought up the deployment again, and then I went to the same address, didn't change our service at all, and you can see that it's working now. So there you go. And so now we've created our service, and we can check our progress to make sure that it knows that our service was created, and it does. And that's basically it for the lab, is just deploying that application. So now you can go ahead and clean up all of your resources. This will delete the cluster. So if you want to do anything else to play around with your Kubernetes cluster, I've still got a good 10 minutes here. You could deploy another sample application on here. You could explore the console more. You can see this API graph is more interesting now. You can also go into the navigation menu and check out the Kubernetes engine page. And this will give you some more dashboards that are relevant to your Google Kubernetes engine clusters that you can check out what's going on with them from the console. It will have some nice dashboards that you can go find and information about your Kubernetes clusters. So you can always go around and check that stuff out, dive deeper into your Kubernetes cluster, and learn about what the console offers there. I'm pretty much done here. So I'm going to go ahead and run gcloud container clusters delete and give it my cluster name, which is demo-cluster. And you can see all this information here about this cluster that I'm going to delete. So I just run that command, say yes. And you'll see that this is now deleting my demo cluster. So this is going to take a few minutes again because it's spinning down all of those compute instances and things. So that's just going to take a few minutes. And once that's complete, you can go ahead and check your progress to get that last green check mark. And now you can see all this information about further exploration. If you enjoyed this and you want to learn more about Kubernetes, there are some quests that we have available on Quick Labs where you can do a few more tutorials and get a nice badge, which is a Google Cloud credential that shows that you've completed these quick labs and you've learned some things about Kubernetes. So there's some suggestions here for quests that this lab is a part of. You can also check out other quick labs. And if you're interested in training and certification, you can find out more about that here and a little bit about next steps. And that's pretty much it. This is a pretty simple, easy to start out with demo. So I hope you'll check it out. Thanks for tuning in to Cloud on Air, hands-on lab, Google Kubernetes Engine. Please visit Cloud on Air for more content from Google Cloud experts. See you next time.